If you've ever seen a photo of a faraway galaxy, it probably has this weird red haze around it. That's not a flaw in the photo or an overactive imagination. That's the galaxy really being red. You're seeing light from stars that are so far away. The light waves have stretched so much they've shifted into the red part of the spectrum. This phenomenon is called redshift, and it is one of the pieces of evidence we have that the universe is expanding. But is it really an optical trick? Okay, before we get into it, I want to say this video was inspired by a viewer who asked what makes redshift work. And while I did consult with an expert for this video, all opinions expressed here are my own. Now back to your regularly scheduled programming. When you look at a galaxy far away, you expect it to look like a little smudge of light. All the stars within the galaxy should be emitting light waves that peak in the visible spectrum, which is where our eyes can see light. If you were to take a picture of it, you'd capture those light waves as a slightly blurry blob of yellow-green light. But if you were to analyze the light, it would basically be a copy of the light we see from stars here in our own galaxy. But instead, when astronomers actually take pictures of distant galaxies, they notice something weird. The light coming from the furthest stars is shifted towards the red end of the color spectrum. So why does the light get redder the further away you look? Well, it comes down to a simple physics concept, the Doppler effect. You might be familiar with the Doppler effect from when a car with its siren on approaches you and then passes you by. As it moves towards you, the sound waves from the siren get compressed, making the pitch sound higher than normal. And then as it moves away from you, the sound waves stretch out, making the pitch sound lower than normal. Light waves behave the exact same way when they move towards us. The waves get compressed, making the light appear more blue than normal. And when they move away from us, the waves get stretched out, making the light appear more red than normal. So the light coming from a galaxy that's moving away from us gets stretched out, shifting the color towards the red end of the spectrum. But why would a galaxy be moving away from us in the first place? Galaxies don't just randomly start drifting away from us. They are literally being carried away by the expanding universe. The universe isn't just expanding, it's accelerating. That means that distant galaxies are moving away from us faster than the galaxies that are closer to us. The light from the most distant galaxies has been stretched so much that it is shifted all the way from the visible spectrum into the infrared part of the spectrum. Because the universe is expanding, every time we observe a distant galaxy, we're seeing it as it was in the past. The light from the most distant galaxies we've seen has taken billions of years to reach us. So when we look at them, we're seeing them as they were billions of years ago. And that's not just true for galaxies. Everything in the universe is moving away from everything else. And the farther away something is, the faster it appears to be moving. We can use this phenomenon to calculate how fast things in the universe are moving away from each other. And that's exactly what astronomers did in 1929 when they discovered that the universe was expanding. So is redshift an optical trick? Well, it's not an optical trick, but it's also not exactly what you think it is either. It's not like the universe is literally shifting the colors of light. It's just that the wavelengths of light are getting stretched out. The color we see is determined by the wavelength of light. So as the wavelength changes, so does the color. If this topic has you feeling like you're falling down a rabbit hole, you're not alone. Sometimes learning about the universe can feel overwhelming, but I offer a different way to learn complicated topics by breaking them down into small intuitive chunks. Their courses range from astronomy to economics to philosophy. I even took the everyday math course, which helped me remember basic math concepts I hadn't thought about since middle school. It's designed for people who want to understand the world around them and those massive open-ended questions like, well, what is the universe? Thanks for watching this video, and thanks again for supporting this SCI show video.